with any sort of virtual machine before? So you guys keep saying you received an image from Edureka that you can use to create a virtual machine. So how many of us has actually created or worked with any virtual machine before, like a VirtualBox machine or a VMware machine? Let's just quickly have a round of answers. Like how many of us has done that before? Okay, so quite a few people have. Neeraj has not. Kumar has not. Who else? Mandar has. Siddhant has not. Aditya has not. Andreas has. Ramesh has not, and Prasanna has not. So almost half of us have, and half of us has not. So there are a few more people that have not. Now, when we actually start talking about Docker or containers as such, right? It's a really good. It's really good to know what virtual machines actually are, because that's when I can kind of compare it for you. Now, if I was to talk about Docker, right, you can think of Docker as an operating system within the operating system. Technically, it's not an entire operating system, it's just the file system. But the point is, you want to have a separate environment within your server that is never affected by the server that you're using, how the server is configured, or anything as such. The point being, all of you would have always come across this problem that something is working on my machine, but it's not working on your machine. It might be something as simple as a software, or it might be something as complicated as an application deployment. So if an application is working in the dev environment, but it's not working in the production environment, obviously there is a mismatch of how exactly the environment was configured. Now, this problem has been around since the application development was discovered or invented. Now, the problem is solved using tools like Docker. What Docker basically does is it creates a consistent environment across all the servers that you have. So when I say a container, you can actually think of Docker like a container. So if I had a hardware container, like you have truck drivers, they move around the containers, and whatever you put within the container, it doesn't really matter what's within the container. But the point is, wherever this container goes, the files that you have inside will always stay exactly the same. It doesn't matter where you put the container. Similarly, if I put my application within a container, it doesn't matter if my application is on an Ubuntu server, if it's on a CentOS server, or any other Linux server, it will work exactly the same way. Now that's, I'm sorry, something's making noise in my room. Quite distracting. Give me one moment, please. Now, following the same example, let's say you put your application in your container and you are, I'm not really sure what's wrong. Okay, that should be fixed now. So let's say you put your application within a container, and now that it is within a container, it doesn't matter where you move it. If you move it from dev to production, if you move it from production to dev, you are guaranteed that your application will work exactly the same way, no matter which server or which environment you put it on. So it solves a lot of problems. The first problem it solves is that if it's working in one environment, it will always work in different environments. The second problem it solves is in today's world, right? Just deploying one copy of the application is never enough. Now think about, let me just bring up a black screen. One moment. Now think about Amazon.com or Amazon.in for an example. So in the entire Amazon ecosystem, if let's say this is the Amazon's website, first of all, if you are in India and if you go to Amazon.in, you would not be served from a server that's in New York. Most likely, you would be served from a server that's somewhere in India. It might be in Mumbai, it might be in Bangalore, somewhere. So let's say Amazon ends up distributing a few copies of their website in the Mumbai region for the clients of India. Amazon.com ends up deploying a copy of their website in Singapore region for the clients of the other Asian countries. Amazon.com ends up deploying another copy of their website in New York region, and let's just say New York and another West Coast region, to make sure they can serve their clients from the US. Now, the point being, in today's world, you can't just deploy an application once and assume that it will always work fine, because the technology is global now. Back in the day, the only thing you had to do was to deploy an application in production once and you're good to go. But that doesn't work anymore. You have to deploy the same application multiple times, even hundreds of times in the different servers. Now think about it logically. Let's say if I give you a very simple application, right? We have addressbook.war at the end of our pipeline. Now I told you you need to deploy this addressbook.war file in 50 servers. Now if you were to do it manually, there are certain steps that you would need to follow. You would need to install Java on a server. You would need to install Tomcat on a server. Now, if you don't know what Tomcat is, it's okay. I'm just trying to lay down the steps in front of you. You need to install Tomcat. You need to copy the WAR file. You need to configure the Tomcat. And you need to place this WAR file in a specific directory in Tomcat. Restart Tomcat, add the DNS records, and make sure it's working. This is where you test if the application is actually working. Now, these are the steps I can think of off the top of my head. Obviously, there is a lot more involved here. But the point is, if you were to run these 8 steps on 50 servers, how long do you think it will take? Also, if it's a team that's doing this, is there any guarantee that everyone would follow exactly the same step? Because everyone has a slightly unique way of configuring and installing things. So it's not guaranteed that the way I deploy my application is exactly like you would do it exactly the same way, even though we're working in the same team. So this is the second problem. Who's going to spend the time deploying 50 copies of application on 50 different servers and have the guarantee that they would all be deployed exactly the same way? The third problem is, let's say somebody was to make some changes to the code. In today's world, this code is not going to stay there forever. It would not likely stay there for a day. The code would change every day. So if every day there was some bug that was fixed in production, who's expected to deploy it another 50 times? And who's expected to ensure that the infrastructure is not broken? That is another problem that my Docker container solves. Instead of doing all of this, if I actually package my application within a Docker container, let's say if this is a Docker container with my application in it, I get the ability to simply run a few configuration files and few commands that will deploy 50 or 1000 containers or any number of containers that I want in matter of minutes. So I don't really need 10 people working on 10 servers at the same time trying to deploy the same thing. As long as my application is containerized, I do have an option to like deploy multiple containers, multiple identical containers of the same application without having to do it all over again. So it makes your application reusable. Once you actually Dockerize your application, you get the ability to simply say, deploy one container in Mumbai, deploy 10 containers in New York, deploy 50 containers in Singapore. Now, obviously, I'm simplifying it, but you actually get to a point where you simply have to write some code and say that these are the number of containers I want to be deployed in these many regions. So your job becomes a lot more easier. You don't spend as much time, and all of this can be automated as part of your continuous deployment pipeline. So once you actually achieve this, you don't even need to be there. The moment the application development team pushes a code to the master branch, the pipeline will be triggered. At the end of the pipeline, it will get a WAR file, and that would be the CI part. And then as a continuous deployment part, it will get the WAR file, it will package the application within a Docker container, and it will deploy the Docker container on all of the servers that you have. So once you reach to that point, as a DevOps guy, you don't even need to be there. It doesn't matter if they make one change a day or 1000 change a day. 1000 changes a day. It would always be deployed automatically without you being there. And in any case, if there is a problem with the code, obviously one of my pipelines would fail, at which point the development team would receive a notification that this is the problem, please fix the code and push it again. That's the idea, and that is the problem that Docker solves. Now that we know why is Docker so popular, now I keep saying you can put your application inside a Docker container, right? The point is, it doesn't matter what your application is. It could be a Python application, it could be a .NET application, it could be a C# application, it could be a PHP application, it could be a simple HTML website. I'm sorry, HTML website. It doesn't really matter what application do you have. You can always package the application within Python. I'm sorry, within a container. That is why container is language agnostic. It doesn't really care about what language is used to write your application, which is also the reason why Docker is so popular in the industry, because it's not targeted on a bunch of companies. It's not just for Python. It's not just for .NET. It's for everything, which is why Docker is one of the major prerequisites when it comes to interviews or when it comes to actually getting a job as a DevOps guy, which is also the reason why I said we will be spending good amount of time understanding Docker, because this is one of the cores of application deployment from the DevOps philosophy. So I hope you at least have an idea as to the problem we are trying to fix, right? I'm not saying you know Docker. I'm just saying I hope at this point you understand the benefits of the Docker that we're talking about. Now Nadeem says, does it reduce the number of production servers and costing as well? So Nadeem, when it comes to costing, you're looking more at infrastructure automation tools. Docker has nothing to do with costing. And when you say, does it reduce the number of production servers? Again, that is not up to Docker to decide. That is decided by the infrastructure team. Again, which is a part of a DevOps, but uh, that responsibility might not be given to you right off the bat if you're new to DevOps. There would be someone senior to you who would be deciding we need 5 servers in Mumbai, we need 10 servers in New York, we need 2 servers in Singapore, so on and so forth. Cool. So at this point, I hope we at least okay. So Andreas says, can you please explain what is Docker all about? I just spent 20 minutes explaining the same thing, Andreas. Now George says, what is the difference between Docker and a regular VM? Yeah, so I'll come to that. George, just bear with me for a few minutes. Jyoti says, so can we call as a mini virtual machine? Jyoti, you can. Technically, a virtual machine is completely different than a Docker container, but you can think of it as a lightweight virtual machine. I'll tell you what the actual difference is in a short while. Nadeem says, which operating systems are supported by Docker? I have heard that we can't run it on Windows. You can, Nadeem. So Docker works on each and every operating system that is out there. It works on Linux, it works on Windows and everything. Cool. So at this point, now Andreas, coming back to you, if you still have no idea what I just talked about, then maybe just listen or pay attention to what I'm saying now, because we've not really started with Docker. I was just talking about the ideas of Docker and why was it, invented in the first place. So we will get started with Docker. Just before we do, might go through a few slides that I think are important for us to look at. Now, this is so the people that has had the question, what is the difference between a virtual machine and a Docker container, right? That's what I'm trying to answer right now. Now, before we get there, let's just see what are the things that we know. So we know something called as a node, right? When we say node, it means a physical server. I'm pretty sure all of us have seen the physical server at some point in time, right? Even the server racks that you see in the movie where they have like thousands of servers in the data center, that's what you mean by a node. So that's a physical server. Inside a physical server, you can actually create a virtual machine. Now, when you say you're creating a Google Cloud server, or when you say you're creating an EC2 AWS instance, this is what you're creating. You're creating a VM. Additionally, inside a node, you can also create a Docker container. Now, Docker is not the only container engine. There are more, like there is something called as Docker that now Docker is the most popular one, and it wins the race like by a huge margin. So there is Docker, there is LXC, there is Rocket. There are a lot many container engines, but Docker is the one that is like owning the industry. So in a physical server, you can have a virtual machine. At the same time, you can have a container. Now, if we look at the slides, it says node is a fundamental requirement to run any application. It is a physical or a virtual machine. So in this case, your node might be a physical server like the ones you see the hardware servers in the data center, or it might be a virtual machine like the ones that we have in AWS and Google Cloud, or even the virtual machines that you create on your own computer. Moving on, just give me one. I'm just trying to find the specific slides that will help us understand what container is. Cool. So what is Docker? You can build, you can ship, and you can run any software anywhere. As I said before, the moment you Dockerize an application, it doesn't matter where you're shipping it, where you're running it. It will always work exactly the same way. There is only one difference. If you have an application that requires Windows natively, then those containers would only work on any Windows server. And if you have a container or an application that requires Linux natively, then that container would run on any Linux server and any number of Linux server. Now, Docker is a tool designed to create, deploy, and run applications with ease by using containers. It allows a developer packaging of an application with all of the requirements such as libraries and other dependencies shipped Ship it all as one package. It ensures that your application works seamlessly in any environment, be it development, test, or production. Now, this is the important part. Once you actually start working with Docker, you have the guarantee that your application will work exactly the same way, irrelevant of which environment you're working with. So you would never have a problem, or you would never have somebody saying, this is working in dev, but it is not working in prod. That would never happen. Now, why Docker? So it eliminates the friction in the development cycle, right? So this, as I said, this has been a problem for over a couple of decades. Development team would always blame the ops team that, ops guys are not really managing the server, the environment is not ready. At the same time, the ops guys would blame the development team that, it's not the servers, it's the application that's the problem. Docker solves that problem. Now, let's just say what is the difference between a Docker container and a virtual machine. Just bear with me for one moment. There is one slide explaining it really well. So I'm just trying to find that slide because I don't know exactly where it is. Uh, where did that go? Just bear with me for one moment here. Right, so here's the difference. So some people asked me, what is the difference between a virtual machine and a container? Now, in my case, I don't really have VirtualBox or VMware on this laptop. Otherwise, I would show what a virtual machine looks like to the people that have never seen that before. But if you really want to see what a virtual machine is and what it looks like, you are welcome. I'll just give you one of the links that I find are reliable. Install Ubuntu VirtualBox Windows 10. Assuming you're working on Windows 10, this will work on any Windows that you have. So go ahead. I hope I copied the link. Go ahead and watch this YouTube video whenever you have the time. This guy will show you what a virtual machine looks like and how it works. Now, what happens is there is a technical difference between a virtual machine and a container. Now, when you install a virtual machine on your server, now obviously this comparison is only for the people that have worked on virtual machines before or that have created a VMware or VirtualBox machine before. If you've never done that before, then don't confuse yourself with this. After the session, watch the YouTube video that I gave you the link of. See how you can install, like I have this Windows laptop right here. Yes, I can also install Ubuntu or any Linux server in a virtual machine in this laptop if I just wanted to try it. Let's say I'm very new to Linux, I don't know how it works. So I don't want to install Linux as a primary operating system. I just want to see what Linux feels like. So without actually affecting my Windows, I can create a virtual machine in my laptop and simply install Ubuntu or Linux Mint or any other Linux flavor in it. So that would solve my problem. So I'm trying to compare this right now for the people that have worked with or have created some virtual machine. If you have not, then watch that video after the session and then try to, understand the context of what I'm trying to say here. So when you install your virtual machine, what happens is you have your base operating system, your host operating system, which in this case is, I'm assuming, Windows 10, because I am using Windows 10. And once you install some software, like let's say VirtualBox or VMware, that is called hypervisor or virtualization. So that VMware or VirtualBox is installed on top of your Windows operating system. Then you decide that you want to try out Ubuntu. You just want to create an Ubuntu virtual machine to see what it looks like. In that case, what happens is when you create a virtual machine, an entirely new operating system inside that virtual machine will be boot up. Now, this is a fully fledged virtual machine, just like what it would look like if you were to install it on your laptop. The only difference is in this case, you're not really affecting your host operating system. It's just, within that host operating system. So it will install the guest operating system, which I'm assuming you want to try out Ubuntu. If you wanted to try out something else, you would obviously be installing that. Now, when you install guest operating system, as a part of the operating system, it also installs the libraries and binaries. When I say libraries and binaries, what I mean is we can run this ls, we can run dir, we can run ls, we can run make dir, and all of those commands, right? So those are the binaries in Linux. When I say libraries, there are also supporting libraries on any operating system that makes all of these things work. So that's what you mean by libraries and binaries. So when you install any operating system, it would have its own kernel, it would have its own operating system, and then it would have its own libraries and binaries. And that's when your Ubuntu inside the operating system would boot up. Now, this is obviously very useful if you're trying to see what an Ubuntu desktop looks like, or what would happen if you were to install Ubuntu on your actual laptop. So if you want to try something out, this is really useful. But let's say if you decide to deploy an application here, that's not really the best approach because this is an actual computer. This acts like an actual computer on its own. It would require at least 2 or 3 gigabytes of RAM just to function. It would require at least 2 to 3 cores of computing power just to function. Now, if you had a very simple Python application that hardly requires 100 megabytes of RAM or 100 megabytes of memory, do you think spending 3 gigabytes of memory and 3 cores on it is a good deal? It's obviously not, because I'm spending a lot more than what is actually required to run my application. Then came the idea of the containers. Now, what happens in case of a container is you have your host operating system, which I'm assuming in this case is Windows 10. Now, if you actually start wanting to work with a container, you will install Docker. That's what you mean by Docker engine. Now, this itself is not heavy. The heavier part was the guest operating system that was installed here in the previous slide in case of a virtual machine. But in case of Docker, there is no guest operating system. Basically, whatever you install, if I was to install an Ubuntu container, this Ubuntu container would not have its own fully fledged operating system. It would simply have the libraries and binaries because it would use the kernel of the host operating system, meaning it would not have its own kernel, but it would still work exactly the same way how an Ubuntu system works. Now that you eliminated the requirement of a kernel and you eliminated the requirement of a guest operating system, still having a fully working Ubuntu file system, you're you're not using a lot of memory and computing power of the server. A container would hardly be an Ubuntu container, right? I know for a fact that Ubuntu container is hardly 100 megabytes. And this Ubuntu container takes 1/10 of a second to start, to restart, or to stop. As opposed to if you're working with a VM, you would at least have what's an ISO? I think an ISO would have almost 2 gigabytes or 3 gigabytes of it would require that amount of space. And once you actually create a virtual machine using this ISO, it would require a lot more RAM and a lot more computing power as opposed to what a Docker container requires. And because this is like a full computer or a full server, it takes a minute or two to actually restart or stop or start, as opposed to 1/10 of a second that a container takes. That's the very basic difference between a virtual machine and a container. That in case of a virtual machine, your host operating system will have, or your virtual machine will have a completely separate kernel than your host operating system. But in case of a container, the kernel of the host operating system is shared within the container so that you don't really need a fully fledged kernel, which requires a lot of resources. Now, this might be a little technical for the people, that are not hardcore enthusiasts of virtual machine and such. But for the people that have worked on a VM before, I hope this is making sense. Now, I really hope you check out that YouTube video. Like, I obviously have nothing to do with them. I don't even know who the guy is, but it's pretty simple to understand, and it's done on Windows. So even people coming from Windows background, it should be really simple for you. The only thing you have to do is install VirtualBox, download an Ubuntu image, and then create a virtual machine using that image. Similar to what Edureka gave you, right? Edureka gave you a virtual machine image, and they asked you that you can use this image to create a virtual machine on your computer if you don't want to install Jenkins and Docker and all of that on your own. So Ramesh, I also hope this is, I'm just trying to touch upon your question in the context of Docker and VM. So now that we have the basic idea of what the containers are, without actually having to go through the slides at this point, let's just start working with them. Now, the first thing I want to do is if I go to my server, if I simply type Docker, it says Docker command not found because obviously Docker is not installed by default. And it's telling me you can run the command apt install docker.io to install Docker. Now we would not be doing that. It's never a good idea to directly run apt install because I think I talked about the remote repos of the softwares when we were installing Jenkins, right? So if this is my server, I talked about it, didn't I? So when we were working with Jenkins, what we did was we copied the Jenkins repo into my server and then we installed Jenkins from that. I mean, we didn't specifically say it, but the server picked up Jenkins from that. Similarly, there's also Docker's own repo that you can add to your server so that you end up getting the latest package of latest version of Docker when you install it. If you were to directly run this command, right, what happens is Ubuntu has its own repo. It's called canonical. So Ubuntu repos are not very frequently updated. They are probably updated once a year or once every couple of years. Now tools like Docker, there is almost like the changes in Docker is very frequent because Docker is still evolving. There would always be some or the other feature being rolled out every another day. So if you end up using this apt install docker io command, right, you would get a Docker version that is much older than what there is out there currently. So instead of blindly following this command, we will look at Docker's official documentation and see how they are recommending us to install the Docker.